My name is Silvana. I have epidemiology and FTP file training in epidemiology for TEFINEP and the CDC. I have administration system information, and today we'll talk about the use for the Google project and the Microsoft projects in really for the willing how download and how converts the data that are downloaded to shiny files in the Python format and the simple code. And they will we see the application that they have the C geographic tools and the public health and the easy use for everything. And with the menu, today the meeting is that the wills to see your presentation would be first as an introduction, how geographic data for points within we create and the application, the public health, and they will see a practical example of how this apply in the Python code and how we can see our example for Tanzania, because of the many students on the Gemini and the living here on the front in Tanzania, I think is a good example for application in this practice. An introduction and for let's start with the introduction in we see it at the Microsoft projects. It's so very free for the public and the basis on the big months and the compare for the OpenStreetMap between the 2004 and 2003. But this don't mean that it's compatible on OpenStreetMap. What the Google, so many codes convert simultaneously and with the mapping OpenStreetMap, and the last update on the March 4, 24 is so very great, where a 58 million edition for the 4 points on the building derived specifically for images for Kalman, Maxar, and Baxter between the 2009 and 2003. These data have a new aggregation for information for the 2004. This weight excludes. The 2040 is the what's exclude for another components, and the all data is available for GIS format and the limitation of the line. Remember when they're talking about, we talk about points, lines, and polygons. And these lines will form polygons specifically, and that will for points for the within addition, and that the free are the multiple use, and they can be given to all the countries and the different areas, for example, in public health, in economy, marketing, amongst other. But in your case, speaking on the global health and the will very direct action from the contains on the outbreaks and the policy action for the among others. And the slice is important. Remember for the data for the JSON at the single country can be very large and very heavy data, and many times for the machines is the way you have range for machines at the low range for computer. Why no? It's a simple use, but it's you necessary at the RAM memory on your computer. But this presentation for the more easy for your computing, and don't doesn't matter in your RAM and the hard disk in your computer, for example. And especially cute and in the extract for areas country for the drop-down list, and they are going to see it for is if you have low capacity in computer in this they normally imagine, but it doesn't matter. This is the slide is the result for everything buildings all the work and the process on the 4.19.4 and the last actualization for 19 in the March in the March. is so very is so very great, for example, for the epidemiology and public health, because they use so many things. For example, the last actualization for a specific for area, for example, and in the emergence of the city or the problem of migration or the migration for the situation for pandemic for COVID-19. How? How do you create the data in this slide? Well, we count the second to how this data create. It's turned out that this data for extract to two steps. One thing is called semantic segmentation, which that does and recognize the pixel for building from the aerials and imagine the using algorithm, the natural networks, or read the natural networks, DNA. And they call these steps is the seed imagine, for example, this, and the translation, the text for buildings, for example, this, and the transformations and the creates in this in the first phase. And the second steps, what was done and the pollination and the convert each pixel detection for the last slide, and then this and the recognize and the adjust for the polygon and transformation in this. How? And the size on the buildings had the estimates for the turn of that day training for natural networks for the estimate they hired a wall for ground using those satellites images combined with hidden measures, and they took the average height weighting and building polygon and the structure without height estimate were defined and the value from -1 and the hidden estimates are given for meters. But we may, as with those estimates, is made a good for the metrics and the specific show the was and majority in case equality. At the last is a good that within design by OpenStreetMap is not perfect with everything. What? Okay. And it's not perfect, but it's 4 points and specifically particularity and the dense, the urban, but I can provide the very good information for country rural areas specific for building 4 point. And this not mean identify wherever it is occurred, unoccupied, abandoned, which the made an order limitation for rural areas, for example. They were stuck to between in 2004 and 2001, and there are so many structured buildings, but it's really useful for many public health in action, because on public health in actions, this is information for actions all the time. It doesn't matter where the source is, it's so good. That's very important is the application for the safe lives. If, for example, in pandemic, is the source is very important for this. And the public health application in the third theme is the public application. I see 3 applications. The first is geospatial model for local public health. This is my article in the GIS for very chaotic for in Colombia, especially for 2 municipalities, because so many we driving for fast food ordering what's stuff of the deaths and all the necessary insulation and contain disease. And the first case is in March, and by May and June, the cases increases. The cities is so very difficult for all the countries. For example, increases is very, very, very is very fast in Colombia. and the installations is very expensive for the country. At the unit, at the technology, and the unit of for the buildings and the other imaginary satellite for the other search in the GIS is very important for us. What's the done at the collect information for inside the cartographic basis? This is it, a country. An application for the people, but in epidemiology alerts is the application for the country. An additional the coordinates for cases to places where we're obtaining the 17% the location for the all the people for the cases for the alerts. And they use the populations, they imagine the satellite, and additionally, some ones the production Colombian spoke about the vulnerability is so best the source in Colombia because on the unit and the 4 points, the buildings and the transformations and the age and the old age and the younger age and the manzana blocks for blocks for blocks and the transformations too for the poor blocks is so very important for Colombia for and the moment in pandemic a transformation for case. The transformation, the data is the spatialization is for this data is the points, the data associated alerts, a kernel density, we then made the order process information so much better that we then densify the cases like community done epidemiology was stably, which the surround of 5 blocks and 5 around is similar to an epidemiology control and the for breaks, for example. I found them using proximities and remotes and individualized cases for they account for data for they on some symptoms because for you it's very important who do less 7 days for diagnosis. Remember in the quarantine is course you the test is the close of neighbor a contain infection and the talking about going to store the break, the quarantine for methods for the useful on the all and the defy true explanation, for example. And this the train is special for the creating a categories and the 200. The score given for the all the buffer and especially information on the spatial overlay and the interpolation is the interpolation spatial in this analysis is very useful for the quality here in the pandemic is very useful because the COVID-19 and the increase for the days for the diagnostic is very dangerous for other people. And the explain is very important because and the overlay and the ways on the analysis is this of over the is interpolation spatial, but the overlay identify neighbors and the action is the moment it's very important and contain and explain information, education, communication, the people. We track the public information about the people. You couldn't imagine what you can information country for their projects, for example, in Tanzania. In so many takes, and you view at the mortality's descent for 1 month is so very important for us. This contained and this project and this containing reality and the mortality and the safe lives for the combined for the information, the satellite and information, the country. And the analysis is the Barranquilla and Cartagena. In Cartagena is similar to the dye is decreased. It's so very important for all. The result for the school for the analysis and interview in Cartagena, 890 Zona did 10 neighbors and 3 neighbors and Barranquilla at the safe for, I don't say this, many lives for very, very important for us. Is the other process, the other application for the prioritization first is the vaccination plan in Colombia, the project at USAID, and the prioritization with the vaccination in Colombia durante 2001, and this arose because the information is will allow degrees for vaccination progress. And the based on the information, USAID contacted me and detected words especially used in product logistics and the supply chains for $5 million in donation from Colombia, increase from the coverage of the vaccination in COVID-19. I don't accept, because I don't access on the 70%. And the is necessary and control for more 18%. What they use on the other layers information for data had the front individual record, vaccines coverage, and the population density. And specifically because in the country, Colombia applied vaccine for age. Additionally, I'm forming gratitude the rules, and this is the process. And the need implementation in vaccine. We look at the municipality and capacity which disagree for data per municipalities, and additionally, the look at the rural coverage for hectare. For information allow they have this great data, how they be able to specify for the more concrete and 100 municipalities, a priority for $5 million and managers on vaccination in areas and the supposed population, allow the elderly population, but additionally the day rural and the supply problem and the need for more help. Vaccination coverage is half susceptible population, the last elderly population, and the rural areas are super problems. And 106 the territories with priorities, which allow increasing vaccination for 3 months. It's so great for us because Colombia is return for the economic activation for other the community for the families is so very important contains and the pandemic results. And the last project in the Proyecto Piloto, the project in Bolivia in the last weeks, because you remember, I don't going to tell about the project in Bolivia where they use satellite images. The object is calculate the size, the national population, and because the last census in Bolivia is 2012. I don't say 2012. 2012. And this is very old, the census in Bolivia. And the contrast very similar census in the scale, the blocks and the sample ratio municipality countries at the for immunization strategy for the public health and the global health and the uses. In this case, we done the review health points and the classification for 680 points and distribution and population and the chosen trained population for children for under 5 years on the age, on the mapping strip, especially primary, secondary, and the tertiary, because of the people near for the vaccination center. They calculate distance between the vaccination, they prove the vaccination points, and calculate distance between the vaccination, and additionally specific techniques that apply for together vaccination points, the rates, density, vaccination, and population. For example, this is the point vaccination and correction for these points because the vaccination in DC is not possible, and the other countries is not possible. An adjustment and all the vaccination points, and this is the result finally, and the population, and imagine the satellite is totally and under the 5 years in this totally, and the identification for 100 municipality, but the priority for 5 municipality. This is the street, for example, and the 4 points they use it for this class, and the 4 points and the point vaccination, for example, and the near, and this point in the near for the vaccination. For the red is most lejos, the far, and the green is so very close for the people, from the people and the via the street, primary, secondary, and tertiary. And they use for the municipalities and the election for 5 municipalities. For the application for the points in this map, they use for activities for the child, the file is the street. For the census, for house for house, for identify for the population is similar to what they imagine for the satellite. Is the correspond they use the blocks and the municipality for the department on the first administrative label, the second administrative label, or 3 administrative label. Let's take a look the code and the application for Tanzania. We're going to that's going following the steps for going from demonstration, because time does not given for apply specifically for age. They call the Google Collaborate, the Collab notebook. And the another class is we are going to see the practical. Don't worry, I am going to give the code and the each of the all elements and the following in the recording apply inside your homes inside of the class, and they're going to Tanzania and they thinking so many collage colleges on Gemini and from the places, and they're going to the line shape and the role in the head made able as the pretty good chase for latest for day at the collaboration and the regional label and the C layer on the wheel. On large size, I can download the each 4 parts in computer at the capacity for the specifically of the region. And no problem, I'm just saying you and do the download these escapes. The first and the launch, the shape and the load, the ArcGIS Hub is so great. The project ArcGIS Hub for the born Nuaris on born Nuari in the countries for the 196 countries is so hard. I participated in this project and the Latin American born Nuaris, and the collaboration is free, but this is so great because and the help and the other countries and the good maps for your country. And the lower shape, the next the lower shapes, and this for the access for your list. And the moment, please. This and the moment, I'm saying you and there. I'm saying you the chat and this. Yeah. And in this page and the explanation for the points from the project, the Microsoft, and the in here is the geographical data for Uganda and Tanzania. And the Uganda and Tanzania, and you click here and the Uganda and Tanzania for everything and GeoJSON data. The Tanzania is here, is no problem because I download you the access for the moment, please, my vinculus for us for the presentation and the chat. You access for the data. And the access for the data in this, the folder Tanzania. In folder Tanzania is a shape and the shape files and the process for the transformations for the other. The Tanzania GeoJSON is this. All the GeoJSON is this. One moment is these all the buildings for Tanzania. This is a layer. The layer is the folder 2 for you see, and the calc quality for the maps is no maps. It's and it's good. It's very good and very small for map. And the Tanzanian regions and the Yundong computing and the capacity for the RAM or for the it's very small. And the possibilities they download the areas. Yeah, the areas is possibility. What is how I'd say? The folder is at the data list data set. The data set for all the countries on the world, the project Microsoft for the only sections. The data list is this, for example, and the for example, like they use on the for the this section, and the download in here. You download the same name and the change name, because at the transformation I don't explain because for why, but is rare the transformation for you changing your download. For the Tanzania's 4, the Tanzania's 4 I search in the folder, and for the Tanzania's 4, I review Tanzania's 4. I don't see. Yeah, the Tanzania's 4 in here. And then this is a code. And this is how code is free, and the similar to access for the my folder, and they convert, and this download archivo. I don't say archive. I forget it. And
Article?
yeah, and the transformation for the help package the format. Help package the format is so very used because the CSV and the GeoJSON data is disorganized in your to-dos. For explain, it's more easy. But you transforms and you help package the format is an indexing. In the indexing for the data is very important. For example, you do data is disorganized for the missing for the other, and the transformation, then the data, you change the variables and the transformation variables and the load and the control of the missing and the indexation data for the transformation for the results. Is the style, the second first in the Python is the style libraries. Is very important for libraries. The other class and the use on the Colab notebook, it's very easy, Colab notebook. And I have a good because you give the RAM for disks. And you don't necessary for so many machines and in your computer for all the process from the data. For the Google Colab, and you give in the RAM and this. And the import the I think, and the people I don't I killing for the coding. The coding is so very easy for the people, and the explaining this code is changed to words, anything, no more, to change to words, and the similar to for many other data is the core, and they import the libraries. The pandas is obligatory in Python. Pandas is library for the process, and the GeoJSON as they use because the format is in GeoJSONs, and the Shapley and geometry is convert the contain the GeoJSON data and transformation on Geo package. This is the line. This the access my Google Drive, and they send me messages are connecting with my drive because data is in my drive. I have permissions, and in my account, I continue to the access for my Google Drive. The next line is on the transformation for the access for the process and the data, and the access my folder, and name is changed for because the change for name, you remember, is only changed in this code, anything else. But the rev and the last is the sentence is because the data is binary. Binary is disorganized and done in indexation. Then the read and the transformation, this process and the help package code. And the CRC is for the CRC is the transformation for you the geographical position in the world. For the countries is not Tanzania for example in Medellin, because in Tanzania in the other world is Latin American, for example. And the process for the 3 minutes. And for example, and additionally, I convert the GeoJSON completes it is the sentences. But don't no current because ISO is very small. It's very slow because at the GeoJSON, all the countries in Tanzania is so very high. And this process and the stop, I moment the transformation, the Tanzania's for this and the look and 35 seconds. It's other computer is more easy. And the verificate the Tanzania's and help package for and Tanzania's for. Yep. Yeah, Tanzania's for help package and download on my computer for you see on the section the Tanzania's for and the charts in the QGIS and the process is this, yeah, and there you see and the Tanzania's 2, Tanzania's 1, and the Tanzania's 4 is this. 4 is very easy for download for specific areas. You see the list for all the countries for all the world for the use for everything. For example, in this for the Finnish is the use in, for example, on population. This is population for Tanzania and in constraint and for example, in this region is the most the population. In this same is the population for age, for sex. For example, you contain and the EDA and diarrhea. I don't say diarrhea in English. Enfermedad and the and the vector, for example, malaria, and the population is the rurals, and the charts for the river, and the charts for the buildings, and the charts for the points, the health, and concentrate and design other under service of health for the people, the transformation and planification for public health for the helps in many countries in the transformation your health. You became the currently for the where I saw where the many people stay and the construction and the public health services and the transformation for everything. And this process and the similar to And then finally, the last imaging is so very important for me because I hope I like this presentation very much. We are living and imagine the shoes tree, DALI tree, an artificial intelligence of bronze says unfolding around Tanzania, surrounded by information and epidemiology data with the also beautiful woman and the fire epidemiology, and additionally draw a passionality epidemiology and reflection on the beautiful things at the happen under this at the picture. That's it for everything. I so hope and so liking and this introduction for the buildings process at the use and public health. That's it for me and change.
Thank you, Silvana. Thank you very much for guiding us through. For some of the folks here, this might have been the first time you've seen a Jupyter notebook. So that's a very useful resource to do online coding. As João Victor made some notes during the presentation, it's very important that I think what you were showing was not Jupyter, was Google Colab. Is that what I see from João's comment? Okay.
Yeah.
So both Jupyter or Google Colab are online notebooks, although Google Colab is more remote than Jupyter. Jupyter, it's a little different. But basically, these are ways to do collaborative coding and share your coding. But with Google Colab, the good thing is you can leverage Google computing capacity. The only downside or the only drawback of using Google Colab to do coding is that we're not able to use sensitive data because everything goes to Google. So we have to be very careful when we're using sensitive data in those notebooks. But it's a great support. Yeah. Cool. All right. Do we have any questions for Silvana?
No, so Silvana, I would like to thank you for your presentation. It was really interesting seeing how the project, the Microsoft project works and how much data you have. The only thing I wanted to confirm is that the process you were doing was to get like small sections from the buildings in Tanzania, right? Like you had the first and the first, second, and third files, but you showed us the process of getting the fourth. And then you need to do that for every one of those files in order to get all the buildings for the whole country. Is that so?
Yeah, because the big file is so hard your computer, and it's probably your computer and no capacity for the processing this imagine the GeoJSON. It's other possibilities, and the construction on the old imagine is for the many images for satellite. For the project, this is the contribution for the many people. At the sign and the people you just imagine the satellite, your contribution for this is imagine and the construction for 4 points buildings, for example. And the units for the files is the possibilities for other people and the use on the big imagine for I say my pantalla again. And this, a moment. For example, this is the all imagine. This is the all imagine, pardon, Tanzania. This is all imagine. I charge, but my computer process is so slow for the charts. Yeah, and a good machine, for example, is so many 4 points for the line. It's so hard. At the other possibilities, at the charts and geo package, for at the and the next and the union for example this region, and it's very common to learn for regions, and you know the code for the regions. This is the code for the regions, and it's more easy and the instructions for for regions, for example. Imagine the raster is more easy, and the transformation this GeoJSON in raster, but it's not easy the process and geospatial analytics because at the loss for the data it's no common transformation and the raster, for example, includes the raster always transformation for the polygons because and they assign the points because the process in the raster the lost data. The precision for the analysis spatial in the in things case.
Okay. Got it. Thank you.
Thank you, João. Thank you, Silvana. So Silvana, a question that I had was, you showed an application of this to immunization and vaccination, but the overall concept of what you're trying to show is that by analyzing buildings and looking at buildings through satellite imagery, we should be able to identify locations where people are living and distribute densities of population, which then helps us basically understand population distributions. Have you seen any work using this to distribute diseases as well?
Yeah, as well. For example, in Colombia, they use and the buildings and transformation for the permission data for unique points, for example, and the sarampion, the measles, in this moment is increasing in the South America. The points for the one people is very dangerous for the free data, but in the 4 points, you are assigning a 4 points allocations is more easy. And the free data for the user for 4 points, for example, in Colombia, the transformation 4 points for the people and the age and the indicators for economics indicator for the poor indicators for the analysis is more easy because your segment and the areas for very small and the don't problem and the habeas data because they are seen and the points and the 4 points. It's so great for the uses for the contribution for the protected data for the individuals, for the transformation for data free for users for the contribution academic, from the policy brief and the other things. And the buildings is so very important for me because for the buildings I make for everything in public health, everything in the world. I don't imagine you and for example you need data for individual cases for the picaduras de serpiente. I don't say in this moment.
Snake bites.
Yeah. And the country, I don't send you points, but you send in the 4 points and the bulletins and the country transformation, the assign for the 4 points and the color and the value. For example, the 1 points 2 cases, for other points 3 cases. It's very similar for you have at a points. And you send your country and this is data. For example, in my country, it's making here. For sending a Danny, you look is these 4 points. Your transformation, please, and the indicators from all the country in Colombia, and the poor, and the age, and the woman, and the sex, 4 points willings. It's the similar the points. I don't have problems for the individual's data. It's transformation for the ubication, for apply for the policy brief or policy makers, and the contribution, and contains the sickness. So many. I very a lot use, and they contain, for example, in the sarampion in Bolivia, in the sarampion in Ecuador, and the measles in Ecuador, and the measles on the Bolivia. I'd explain the use of the 4 points, and the use for contains the cases for measles, because one case measles for 7 and 37 cases for the 1 cases is so hard, and the rate of the mortality is so high. But if they contain the sickness and the 4 points and the blockade, for example, this near and the school. Okay, this near and the school. This near and the park, and this near and the park, and the blocking in this here on the 9 blocks is blocked, and the contains, but they expand the contains for the public health, for example, in and contains outbreaks.
Yeah, so that's something I'm very interested in, is using the layers, as you just mentioned, and trying to use that to predict risk factors for some conditions, and then using the risk factors geographical distribution to then allocate disease prevalence, which I think it's something that would be very beneficial. And I haven't seen a lot of people do that. I've seen people do that for immunization, but that's easy because if you have kids, you need vaccines, period, right? But it's harder for cardiovascular disease because it's not just a direct path, or snake bite because it's not, I can't distribute the points randomly because the space is important, right? So I've been thinking about this for a while. The other question that I would have is the building mapping good enough to find rural buildings in rural settings like indigenous villages?
It's not perfect data, but the data is you compare your OpenStreetMap, for example. It's so it's 80% for more or less in the contribution for this. On the anything is this in this moment. For the future, this is so better because of the AI is the process and the advances all the time. But in this moment, and the containing firm, you see in my process in the decrease on the mortality and decrease for cases. I contain the sickness. I increase the coverage and vaccination. Is the use is possible? Yeah, is the use is possible. It's not perfect, the data. For the everything data is not perfect. The epidemiology say always the data is not perfect always, but the contributions on so many years is so better, and you works for this data and the process and the contribution for the other data for the best base.
Okay, that makes sense. I would like to make a comparison and try to see how well we can find small villages in remote settings using building mapping, because that would be very good. If it's not, then that's something that we should think about.
But in this moment, it's so very, very excited for geographical intelligence or data science. because they free many data. For example, Google Engage, it's so great, and the file is liberated for the last month for the all the data. For example, the data is incredible for the foods, for the nutrition, for the weather, and the weather subterraneans, for example. It's so many data for the free in this moment. Is the opportunity, for example, and Gemini they use for the contribution for the countries and we didn't need, and the process and the public health and the other process and the noise stay and the clinic. Excuse. It's the same, and they always use the clinical data. The clinical data is so great, but it's advances of the data for the health of the countries, for the contribution on the public health and the prevention and promotion. Is very important, prevention and promotion, and the use of data for the prevention and promotion and the clinical and the create, because the people is the más saludable for the contributions of the city for health. Is the PAHO and the WHO would say everything day. The contribution on the academics is research is the contribution for the health cities. In the health cities and the contribution and the prevention and promotion for the sickness. And they use the geographical data is the possibility for these places, for the change for the planifications of the urbanization, the construction for on the parks, the construction for the exercise of the parks, for the construction for the space for the country for the due quality and the good air is possible in this moment for the liberation data for the geographical data. Eso es lo que pienso.
Well, I think it makes a lot of sense, and there's definitely a lot of potential here to use, and we need to understand the limitations well enough to know how to use it properly, as you said. So, yeah, fantastic. This is a tool that I think we need to use more and more. Thank you, Silvana, very much.
Thank you, and excuse for my English. I prepared my presentation, but I practice in the stay here is for the practical my English, and so excuse for when si tuve algún error. I so sorry because I trying all the time on the practice my English for this work.
Of course. Well, your English was great. Thank you very much for presenting in English.